The analysis of truss is generally done with the help of joint method and section method. Generally, we use joint method for the computation of entire members in the truss, while we use the section method for the computation of certain members in the truss. So let us see the way we can solve the problem associated with the truss with the help of section method. We are asked to determine the internal forces developed in the member BD, CD and CE. So we have a given truss as shown in the figure, and we are asked to determine the member forces that are developed in the member BD, CD and CE. So here we are not mentioned in the question that we have to use the joint method or section method. Rather, we are given certain members to find out in the questions, and we can easily notice here that we are given the only few members that are BD, CD and C. So we need to make an analysis within ourselves that we can use the section method in such a case. And for using section method, we have to be conscious about selecting the section that is to be cut. Here we select a certain section through which the given member forces are passing, and we just assume the given member forces as the tensile members for the further computations. So let us see the solution of this question. Here in the question there are 5 panels given. So we have the truss section consisting of 5 panels, and the distance of each panel of the truss is 1.8 meters. So the total distance of the total horizontal distance of the truss member is 1.8 into 5, that is 9 meters will be the total distance, horizontal distance of the truss member. Likewise, the horizontal distance between member A, B, BD, DF, FH, HJ and JK is given as 1.5 meter each, and using these dimensions we need to calculate the support reactions at A and K. Here at A there is the hinge support and at K is the roller support, and we all know that at the hinge support there will be 2 reactions developing there, and at the roller support there will be only 1 reactions, and we have assumed the directions of the reactions in the above truss as shown in the figure. Now we shall compute the support reactions based on our assumptions. Now we need to compute, or we need to apply the equilibrium equations in order to determine the support reactions, and we all know that the equilibrium equations are summation of Fx equals to 0, summation of Fy equals to 0, and the summation of moment about any point equals to 0. So we shall use such equilibrium equations for determining or solving the statically determinant truss. Here firstly we will just use the summation of moment at point A equals to 0, and I have assumed that the clockwise moment is positive. It is not necessary that we can assume clockwise moment always positive. You can also assume anti-clockwise moment as positive and calculate the further calculations based on this assumption. Okay, so at point A we can easily see that this RKY is giving our anti-clockwise moment, and all the external loads, that is 3 kilonewtons, 6 kilonewtons, 6 and 3 kilonewtons are respectively. So rather this 3 is not giving any moment here, up to 6 kilonewton meter, that is giving us clockwise moment. Okay, so in the given figure we can easily see that RKY, this reaction RKY is giving us anti-clockwise moment at A, and the loads like 3 kilonewton, 6 kilonewton, 6 kilonewton, again 6 kilonewton, again 6 kilonewton, and again 6 kilonewton is giving us clockwise moment. So we can easily write minus RKY into 9. So 9 is the total distance of AK. So AK in the figure is given as 9 plus 3 into 9. So 3 is also, again acting downward at K joint. So it is again giving us clockwise moment, plus 6 into 7.5. So 7.5 will be the distance from A to J. So 6 into 7.5, likewise 6 into 6 plus 6 into 4.5 plus 6 into 3 plus 6 into 1.5 equals to 0. And if we solve this, the value of RKY shall come out to be 18 kilonewton direction. That is summation of Fy equals to 0. And assuming upward direction as positive, we can easily write RAY plus RKY acting upward minus 6 minus 6 minus 6 minus 6 minus 6 minus 3 minus 3. So that comes out to be 6 into 5 minus 3 minus 5 minus 3 equals to 0. So if we solve this, then the value of RAY shall again come out to be 18 kilonewton. And from our inspection or journal inspection, as there is no horizontal load acting in the truss member, then we can easily write RAX equals to 0. So this is written with the help of the horizontal equilibrium equation, that is summation of forces in x direction equals to 0. So this RAX shall come out to be 0 kilonewton. After calculating the support reaction, now we shall cut the section. For cutting the section, we need to be sure that the cut section has at most 3 unknown members. So we need to cut a section in such a way that the cut section has at most 3 unknown members, so as to use the equilibrium equations, summation of forces in x direction equals to 0, summation of forces y direction equals to 0, and the moment about any point equals to 0. So we must have at most 3 cut members that are unknown. So this is the general thing that we need to know before cutting the section. Okay, now again we also have to take into consideration that while cutting a section, we need to cut the section in such a way that the given members are computed easily, as in this case we have B, D, C, D and C members unknown. So we can cut a section like this, that is A section. We have cut a section AA, so that the members BD, CD and CE have to be cut, isn't it? So we have cut a section in such a way that the member forces in BD, CD and CE can be easily computed. Okay, and after cutting the section, we only need to consider the section towards the left side or sections towards the right side, that is the section left from the cut section or the section right from the cut portion. So in our case, since there are less number of forces in the left section after being cut, then we shall assume the cut section in the leftward side. So we shall assume the cut part only in the left side. In our case now, it is not necessary that you have to assume the section in the left side only, but in our case the section in the left side after being cut as shown in the figure is very much easier for computation, so we shall assume in the left section. Now friends, one thing we need to compute is to determine the angle associated in the given truss with the usage of the given geometrical figures or arrangement. Here the angle alpha and the angle theta is to be determined. Here the angle theta is determined with the help of this big triangle. So AF this, so this triangle, so if we assume this as x, then AFX, this triangle is used for the determination of theta. So we can easily use tan theta equals to distance. The vertical distance is 2.4. this is P, and the base can be easily determined as, so this is 9 meters, and so this will be exactly half of 9 meters, that is 4.5 meters. So 9 by 2, that is 4.5. So tan theta is given by 2.4 by 4 by 4.5. Then the value of theta shall come out to be 28.07 degree. Likewise, friends, the value of angle alpha can be find out with the using of this triangle as shown in the given figure. So triangle CD and Y. So if we assume this point as Y, so CDY shall give out the value of what? Angle alpha, isn't it? So we can easily write tan alpha equals to P is 1.6. So 2.4 is the total distance of vertical distance from the base to the apex point or crown point. So up to this level, the vertical distance shall be 1.6 divided by the base. So base is what? So this is the distance of the base. So how this can be computed by? So this amount of distance is what you say 1.5 meters, that is given in the equation, and this small distance is 0.3. So if we subtract 1.5 minus 0.3, the base will be coming out to be 1.2. So we can easily find out the value of this angle alpha as 53.13 degree. Now we have taken a section A and we have considered only the left part section from the chord portion. Okay, so next our aim is to write the different forces that can exist in the chord section. So we can easily see that from the chord section only 3 member forces, that is FBD, FCD and FC are unknown, isn't it? So there are 3 unknowns and we have 3 equilibrium equations to solve out this, so they can be easily find out. Again, we have assumed that all these forces that are occurring in the chord section are tensile in nature, and on the further computation, if these forces are come out to be negative, then they shall be written as compression. Okay. The other important thing that we need to assess is that which joint we can apply the moment, so that we can easily find out the unknown member forces. So which joint is that? So from which joint we can use the equilibrium equations, so that we can easily find out the unknown member forces. So let us see. So at joint A, so if we consider at joint A, what will be the unknown forces? Let us see. So at joint A, the member forces in FBD shall be 0 because there is line of axis, so there is no any perpendicular distance. So FBD will be giving us 0, and FCD. So FCD horizontal component is not giving us, only the FCD's vertical component will be giving us, and FC is again 0 because there is no any perpendicular distance, so it is passing through joint A. So if we compute the moment at point A, that will be giving us what? The vertical component. So FCD, so FCD one component will be there, so we can use the moment at joint A. So what if we use the summation of moment at joint B equals to 0? So if we use the summation of moment at joint B equals to 0, then the FBD will be going to be 0, isn't it? There will be FCE and there will be FCD. So there will be 2 unknowns in this case. So that 2 unknowns. So there will be 2 unknowns. So that cannot be solved directly. So let us see what if we have just taken the summation of moment at point C equals to 0. So if we use that, what will happen? There will be FBD giving us, isn't it? So FBD will be giving us, if we use the summation of moment at point C equals to 0, then FBD will be giving us, isn't it? And FCD, so FCD will be going to give 0 because there will be no perpendicular distance in that case, and FC is again 0. So we shall find only the FBD as unknown members if we use the summation of moment at joint C equals to 0. So let us see that what will happen if we take the summation of moment at joint C equals to 0. So I will take the summation of moment at joint C equals to 0, and I will take clockwise as positive. Then what will happen? So in that case, what will happen is that FBD into cos 28.07. So this angle has already been computed as 28.07, that is angle theta. So cos 28.07 into FBD. So FBD into cos 28.07 into perpendicular distance. So cos component will be acting this way, so perpendicular distance will be 0.8, isn't it? So this is again giving us clockwise moment. Again, FBD vertical component is FBD into sine 28.07, that is giving us again clockwise movement at joint C. So that is written as positive, and the angle is 28.07, and the perpendicular distance in this case is 0.3. So we can write this. Likewise, we have this 18 kilonewton giving us clockwise moment, so we have written plus, and this 3 kilonewton is giving us anti-clockwise moment. Minus 3 into distance is 1.8. So if we equate it equals to 0, then we can find out this value of FBD, that is force in the member BD. So in this case, force in the members BD can be computed as minus 29.75 kilonewton, and it is the compressive force. So what is the amount of compressive force that is existing in the member BD is 29.75 kilonewton. That is the compressive force existing in this member BD. Likewise, now we can use other equilibrium equations, that is summation of Fy and summation of Fx, to compute the remaining two forces, that is FCD and FCE in the given truss. So now let us take the summation of forces in y direction equals to 0 and taking upward direction as positive. What we can write? So we can easily write this 18 is going upward, so we have written plus, and minus 6 is coming downward, so this is coming downward, minus 6 we have written, and minus 3, so minus 3 we have written because 3 is again coming downward, plus FBD sine 28.07. So this FBD vertical component will be acting upward, so at an angle of 28.07, that is theta, and what this FCD vertical component is again acting upward, so FCD into its vertical component is sine 53.13, that is alpha we have computed earlier, isn't it? So equals to 0. So this is the amount of vertical forces that is acting. This is 3 kilonewton, 18 kilonewton, 6 kilonewton acting downward, the component of FBD acting upward, and the component of FCD acting upward. So if we solve this, then we can easily find out the value of FCD as 6.25 kilonewton tension. Here one thing we need to be careful while solving the question is that here we have assumed all the sections to be tensile, and here we have obtained the value of member forces as minus 29.75 kilonewton. This is the value that we have obtained while we are assuming the member forces to be tensile. So while writing the value of member forces, you need to write the value with the sign. So you need to remember that while writing the value of FBD in the consequent expression or relation, then we need to write with the sign. So if we miss the value of sign that is coming in this case, then our problem solution shall be come out to be wrong. So we need to write with the sign that is coming in the given problem. So we shall always write with the sign. So the FBD value is what? Minus 29.75 kilonewton. So while substituting the value of FBD, we need to write minus 29.75 kilonewton. Okay, isn't it? So if in this case, if it had been coming out to be plus 29, then we will say write plus 29.75. So this is the way we can write this expression. So if we solve this, the value of FCD that come out to be 6.25 kilonewton. Now friends, using the third equilibrium equations, that is summation of forces in x direction, that is horizontal direction as positive, and assuming the horizontal direction, that is right direction, as positive, what we can easily write is that FCE acting horizontally, isn't it? Likewise the horizontal component of FCD is again acting rightward, and the horizontal component of FBD is acting rightward. So we can easily write FC plus FCD cos alpha plus FBD sin theta, FBD cos theta equals to 0. So cos theta is what? 28.07 and alpha is 53.13. If we substitute this, then the value of the remaining force FCE that will coming out to be 22.50 kilonewton, that is in tension. Okay, again here we need to be careful while substituting the value of member force that is obtained in the member BD. So what we have to be substituting in the FBD is that whatever the value that is coming with the sign, we need to substitute in the consequent expression. So minus 29.75 will be the value of FBD. So if we solve this, the FC will be 22.50. Finally friends, what we need to write is that we need to make a table as shown in this, and we need to write the member force and the magnitude of the member force and with the nature of the member force. So the member BD will be magnitude of 29.75 and it's compressive in nature, and CD is 6.25 tensile in nature. Likewise C is 22.50, and again it is what? It is tensile in nature. So this is the way we can solve out this type of problem in the truss.